Find the surface area and volume of a closed cylindrical container with radius 5 centimeters and a height of 34 centimeters. Um, we will use a few formulas here in order to do this. I'm first going to sketch the shape because that helps me and helps me visualize what we're doing. So that's the cylinder, and if I the radius of the circle is 5 centimeters, and the height is 34 centimeters. We'll tackle the surface area first. And the fact that it says a closed cylindrical container means that there is a top and a bottom surface. If the question asks for an open cylindrical container, that would be like a cup of water. There wouldn't be a top surface. It would just be like open. But this one is closed. So let's do area of circle equals pi r squared. And how many circles are part of the surface area of the cylinder? The top and bottom, so 2 of them. So total area of circles equals 2 times pi r squared. And we can just plug that in. 2 pi times 5 squared is 25, so it would be 50 pi. All right, so that's part of it, just the circles. Now we need to look at the side of the cylinder, like the side of the barrel, if we thought about it that way. And I like to draw it like that. Like if we imagine this the side, deconstruct it, I guess. It would be a rectangle. Like if it was paper and we took scissors and cut it, we could unroll it and it would be a rectangle. So right here we have the height, so that's 34, and this distance is the same as this distance all the way around. And that distance is the circumference of the circle, which, using our formulas, is 2 pi r. Now to get the area of a rectangle, it's just height times width. So I'll just call that rectangle area equals 34 times 2 times pi times r. I do a little bit of that in my head. So 340 pi for the area of that rectangle. So total surface area equals, we add that plus that, so we have 390 pi. And then don't forget the units, centimeters squared. The next part of the question, find the volume of the closed cylindrical container. There's a formula for the volume of the cylinder. It's going to be pi r squared times the height. And we know these values, we can just plug them in. So, and then I'll explain a way to think about how they get that, if in case you forget. So we have pi times 5 squared times the height is 34 equals, I'll use my calculator, equals 850 pi. And don't forget the units. They're both in centimeters, which makes this easy. We don't have to do any unit conversion. So 850 pi centimeters cubed, because it's volume. Okay, so those are the answers. If you ever forget this, one way to think about it is I compare it to like the volume of a box. You have 3 dimensions. You have height, width, and depth. And a volume, by definition, is a 3-dimensional measurement. So you will need to identify all the 3 dimensions and the useful measurements that make up those dimensions for the object. And when you're looking at a cylinder, comparing that to a box, you could do a calculation like this. That's a terrible box, but you could figure out the base of it, that dimension times that dimension, and you'd have that base area multiplied by the height, and you would get the volume of that box. The cylinder is very similar. We figure out the area of the base, this bottom circle, and then we multiply it by the height. And that's how I think about it. We know the base area because it's a circle, pi r, or pi r squared. We just use that. And then we multiply that by the height, which is simply h. So nothing too complicated, but it's a different way to think about it in case you forget.